Welcome back. In this video, we're going to do example 6.2.1. We're asked to set up the triple integral of a function f of xyz with no rule given over the solid that is the paraboloid below the paraboloid z is equal to 1 minus x squared minus y squared and above the xy plane using 4 different orders of integration. So let's sketch that paraboloid first of all. So we know from quadric surfaces that this paraboloid is facing down because the coefficients of x and y are negative. It's got a circular base in the xy plane, so let me draw that in. And we've got the paraboloid coming up to a high point sort of 1 here on the z-axis. And this, if I want to make it look a little bit better, that's tucked in behind, so I'll make those lines dotted. So there's our paraboloid. And now we want to integrate over this in 4 different ways. So we're going to start by using a type 1 solid, which is going to be bounded above and below. And so our below bound is going to be, well, it's going to be this solid that I'm shading in gray there, which is actually the xy plane. So below, we're going to have z, I was going to write x, but no, z is equal to 0, which is the xy plane. And above the upper solid, well, the upper surface, I should say, of the solid is the paraboloid itself. So that paraboloid is going to be, well, as it's given, z is 1 minus x squared minus y squared. That is our upper, or above. So using the triple integral formula from the previous video, we're going to go from z is equal to 0 to 1 minus x squared minus y squared of whatever function this is, f of x, y, z, dz, and then we've got to integrate this over some shadow region d, dA, and that shadow region is going to be down in the xy plane. Well, we can see what that is. In fact, I've shaded exactly that down there. That is going to be the circle where z equals 0. If z is equal to 0, we've got the circle x squared plus y squared is equal to 1. There's our circle. That's our region D here. And so we can set this up either as a type 1 or a type 2 solid. So let's set it up as type 1. If we set it up as type 1, we're doing above and below. And so we have y is the positive root of 1 minus x squared, and y is the negative root. I would never actually integrate this way. I would switch to some sort of polar coordinates. In fact, we're going to see that in a later video. Triple integrals matched with polar become something called cylindrical coordinates. And the x is going to go in the unit circle from minus 1 to 1. So we can set up our integral here as the integral from minus 1 to 1 in x, the integral from minus the root of 1 minus x squared to the root of 1 minus x squared, of the integral from 0 to 1 minus x squared minus y squared of our function f. And the order that we've chosen is dz, dy, dx. So just like the double integral, the constants always go at the very outer integral, and you start integrating on the inside and you work your way out, which we're not going to do in this video, but we'll do it in an example in the next. So there's one of our 4 orders. We're going to do another one simply by rewriting our region D as a type 2 region. So we'll cheat a little bit. It's not a cheat at all. It's just not rewriting our solid. So if we go right and left, let's choose another color here, and write our function this way, then we're going from minus 1 to 1 in the y, and we're going from x is minus the root of 1 minus y squared to x is plus the root of 1 minus y squared. And so we would get the integral from minus 1 to 1 of the integral from minus the root of 1 minus y squared to the root of 1 minus y squared of that same inner integral of f of x, y, z, and this time dz, but dx, dy. So that's one way that you can get a different order of integration, is just by re-expressing that shadow region D as a type 1 versus a type 2 region. So that's kind of boring. We really want to learn about re-expressing solids as different types of solids. So for our last two types, we're going to re-express that paraboloid as a, instead of upper and lower bound, but a front and back bound and a right and left bound. So let's redraw our paraboloid here, and if we have, so let's get our circle in one thing at a time. There's our paraboloid. If we want a front and a back bound, that means we want to cut the paraboloid right down the center and have two graphs in front. So we'll have, I said that wrong, we'll have two bounds, one in front, one in back. So our paraboloid in front, if we cut it right down the middle, will be one surface, and our paraboloid that'll meet here but go in the back will be our other surface. And so that paraboloid in back and the paraboloid in front are both going to be in terms of x. So let's take our paraboloid here, x squared. I'm solving for x is equal to 1 minus z minus y squared. And if I take the root, therefore, in front, I'm going to get the positive root. X is equal to the root of 1 minus z minus y squared. And in back, I'm going to get x is minus the root of 1 minus z minus y squared. So that is going to be the inner integral. So from the negative root to the positive root of our function f of x, y, z, that's in terms of dx. Now we have to set up that integral as a double integral over some region d, dA. And so what is the shadow region? Well, the region is going to be right in the center here on the YZ plane, and we can see that region if we graph it separately in the YZ plane. We're going to have this. So this is Y, that is Z. There's our region D, which is the projection or the shadow of the paraboloid down onto the YZ plane. And if x is 0, then we are getting the function z is equal to 1 minus y squared. And so we then have to describe this as either a type 1 or a type 2 region. I'll go with type 1. And so we have from minus 1 to 1 on the y, right? So minus 1 is less than or equal to y is less than or equal to 1. And the z will travel here up from 0 is less than or equal to z is less than or equal to 1 minus y squared. So if I go in that order with a front-back bound, I've got the integral from minus 1 to 1, the integral from 0 to 1 minus y squared of that same inner integral, which is big and long and messy. The bounds are, anyway, the root of 1 minus z minus y squared, and our same function. So the last thing left to do is to set this up as a, again, let me concentrate, too much happening, too many words, too much writing at the same time. dx, what did I go in? dz, dy is the order there. And the last way that we could go is as a front and, no, that was front and back, as a right and left bound, right? I could get another order just by switching. I could get another order by switching this as a type 2 region, but let's go and re-express this, the same paraboloid, now as a type what is it? Type 3 solid. So if I have my paraboloid, same deal here, looking like this. Now we want a paraboloid which is in front, like this, and one that's in back, a lot easier to draw this way, as a back bound there. And so we're going to solve for y, and it shouldn't take you much to see that your front bound is going to be y is equal to the root of 1 minus z minus x squared, and your back bound is going to be y is equal to minus the root of 1 minus z minus x squared, and you can go and set up the bounds the exact same way. For the region D, we're going to have the region now that is this parabolic shape now on the xz plane. I forgot to label my axes, x, y, z. So in the xz plane, I'm going to have the analogous parabola where z is equal to 1 minus x squared. And so our triple integral will be from minus 1 to 1, that's here, from 0 to 1 minus x squared, that's going up this way, of that inner integral from minus the root of 1 minus z minus x squared to the root in red, 1 minus z minus x squared minus x squared of f of x, y, z. And then really the hottest part for me sometimes is remembering the order that I've gone in. This was a dy bound, this was a dz bound, and dx. So there is the paraboloid, the integral over the paraboloid, set up in 4 different ways. One of them is just the region set up as 2 type 1 and type 2, and then the others are set up as 2, 3 different kinds of solids. In the next video, we won't do 6 different ways or 4 or any of that matter, but we'll do an example of one in a single order.